Here we have the 2012 acid-base question. We can see it came up in question 10 part B, so it was only worth 25 marks this time. So the first thing they ask us is to define an acid according to the Bronsted-Lowry theory. So we know that a Bronsted-Lowry acid is a proton donor. The second question is, what is a conjugate pair? Okay, so a conjugate pair consists of two substances that differ by a H+, or a proton. Okay, so then they give us an equation for the dissociation of a weak acid, which is also an acid-base indicator. So they're using this HIN to represent the fact that it's an indicator, but also it contains this hydrogen ion, so it is a weak acid. And it dissociates to produce that H+ ion and to produce the In- ion. And we know that that ion is purple, but when it has not dissociated, it is green. Okay, so they ask us to state and explain the color change when a few drops of the indicator are added to sodium hydroxide, 0.5 molar sodium hydroxide. Okay, well, let's think about sodium hydroxide. That contains two ions, or it's going to dissociate into its two ions, Na+ and OH-. Now, what this OH- ion is going to do is it's going to combine with the H+ ion to produce water. So the OH- ion is going to combine with the H+. So effectively, it's actually using up that H+. So if the H+ is removed, remember, by Le Chatelier's principle, the forward reaction is going to be favored to replace the removal of that H+. So the forward reaction is favored, which is going to result in a purple color being produced. Finally, then, they give us two calculations. So the first one is to calculate the pH of a 0.5 molar sodium hydroxide solution. Okay, so we have our equation for calculating pH. We know that it is minus the log of the base 10 of the hydrogen ion concentration. Now, the sodium hydroxide is a base, so we are going to have to use a couple of other equations where we know that the pH is also equal to 14 minus the pOH. And we calculate the pOH in the same way that we calculate the pH. So it's minus log to the base 10 of the OH- ion concentration. Now, we know that sodium hydroxide is a strong base. So if it's a strong base, we know that it fully dissociates into Na+ and OH- ions, which means that if we start with 0.5 molar sodium hydroxide, we're going to get 0.5 molar sodium hydroxide ions, or hydroxide ions, being produced. So we can calculate the pOH by finding minus log to the base 10 of 0.5, and that's going to give us an answer of 0.3. And now we need to put that into our equation for pH equals 14 minus 0.3, which is going to give us an answer of 13.7. Now, the next calculation they ask us is the pH of a 0.1 molar solution of the indicator given its Ka. So we know that if we've got a weak acid, we need the Ka, because in order to find the H+ ion concentration for our pH equation, we need to find the square root of the Ka multiplied by the Na. So we are told that the Ka is 2 by 10 to the minus 5. We know that the molarity is 0.1 because we were given that in the question. So that's going to give us an answer of 1.414 by 10 to the minus 3 moles per litre of our hydrogen ions. And then all we have to do is pop that into our pH equation, minus log to the base 10 of the hydrogen ion concentration, 10 to the minus 3, and that's going to give us 2.85. So that is the 2012 question, a nice little question for 25 marks.